everybody, my name is Yalda and I'm going to be one of your SportWord online guides.
So hey guys, I wanted to finish this problem for you. One, because I was a little spacey during the review, and because we had the two groups, I felt a little uncomfortable like doing everything fully from scratch. So I wanted to at least do a good job with this and do it from scratch. So probably echo both sections, probably more towards Vilicek, but for both it should be good. And then also, I want to kind of incorporate all those things into one problem so we can get a lot out of it. Okay, so let's try this. So let's say, and I paraphrase this, let's say you have a plane and it's perpendicular to 113. Okay? So what you want is you want to find the equation of a line parallel to that plane, right? But passing through the point 110. So let's first start with this. Like in the review, we did mention something about this. What I want is I want him perpendicular to this guy. Well, I know the plane's perpendicular to him, but I also want the line perpendicular. But you know the requirement. To get somebody perpendicular, all you need is you need some vector, right? We need to figure out here, question marks all the way around, such that the dot product is 0. Okay, so pick anything you want. I think in this case, maybe just to make it really simple, we'll do something like let's do this. Why don't we have 4 and then -1 and then -1. Do you guys agree? Because if I take the dot product, 1 times 4 is 4. 1 times 1 is -1. 3 times -1 is -3. So you really would get 0. So these two vectors really are perpendicular. Okay, then I'm going to use that parameterization game, remember? So if this vector is perpendicular, so that's the one I want. So the plane is perpendicular to this guy. If I have a line parallel to the plane, it too must be perpendicular to this guy. That's exactly what I want. Okay, so now I have this guy. He's the correct direction, but this is just one vector. Remember the idea behind parameterization? You don't want that one vector, you want the entire line. So to get that entire line, you need all multiples of this vector. Which is totally fine, so I'll put this t in here, right? Where t can be any real number. That will get us a line, okay? But the trick is that's a line based at the origin. So what I want to do is I want to make sure that it passes through 110. And we saw how to do that, right? Remember, to take this guy who's at the origin and make sure that he goes through the point 110, what I need to do is take the vector 110 and add it, right? Because if I take 0 plus 110, it takes me up to the right point. If I take another guy over here, right, and I add 110, the vector to it, it would push me the same way. So I'm basically taking all the points in this line, pushing it up to the guy I want. Okay, so again, that was from the review. So let's get a final solution to this. So, take the original guy based at the origin, push him up to include 110. So it's going to be 1, 1, and then 0. Okay. So that is the parametric equation of the line we want. Okay. If the prof wants you to clean this up, I multiply t through everything. So I get 4t, if I forget to add this guy, plus 1. Again, negative t, plus 1 here, negative t, and then I guess plus 0. Okay, so the final part to this problem would be, so one last thing, so we just got the parametric form of the equation of the line that's parallel to that plane, but passing to that point that we wanted. That's all they're going to ask you to do. So someone, I believe she was sitting right over there, she asked me really cleverly, like, you know, I was kind of mentioning at the end, if you had to translate it back to the XYZ thing, what would you do? And I was showing some defining relationships, and she said, well, what would happen if like it didn't turn out that pretty? Well, the thing is, they're not going to make you transform it. Okay, the reason why is, when we have some setup like this, because I'm using 3 guys here, I'm defining a plane, okay? So I can't really use this to capture a line. So that's pretty much where it'll end. So for example, do you remember the one where I'll just make up something? So let's say we had something that looked like this. Okay? Okay. And let's say that was the parametric form of our line. If we had this, we would be done. You would not be asked to translate this line, because it's a 3D line, right? Going back to this sort of form, because we basically can't do it at this point, okay? Or, in general, it's very hard for us to do that. Okay, so what could they ask you to do? It depends on the prof, but sometimes your book does something called Symmetric Equations. Well, this is what I was talking about. You can basically start to do this. To get this sort of thing, right? These defining relationships. And the standard way to do this, because I was just sort of doing it ad hoc, because the problem is really easy, is if you want to standardize this, solve for t. So t over here would be x minus 1, t over here would be y minus 2, and t over here should be z over 2, right? And then what I can do is, since they're all equal to t, you can set them all equal to one another. If I set them all to be equal to one another, we'd end up getting this. And this is called a set of symmetric equations, okay? And it's just a nice way of showing how x and y are related, y and z are related, and z and x are related. But that's pretty much the best we can do. So once you're down to this, you're good to go, okay? So again, I kind of breezed through that during the review because I don't think they'll really test you on this, but just in case, okay? We will not translate this to something like this, because in this format we can capture the plane, but doing the line is a whole different deal. In fact, it's not really amenable to this. It's much better like this. Okay. So good luck on your exam. Sorry it was a little low energy and a little spacey, but if you guys have questions, please feel free to come by any time. Tomorrow, or this coming Sunday, I'm going to be teaching MCAT pretty much from 6 to 9. So anytime, I guess, in between, like 3, 6, or 9, I should be free if you guys have questions. So good luck.
Give us your feedback so we can improve our videos.